Hello all, and thank you for listening to Mr. Laxton's video on these Algebra 2 Section 2.1 notes. We're starting Chapter 2 today. Alright, thank you for spending your morning, your night, or your afternoon, whatever, whenever you're listening to this video. Thank you for spending that with me. Alright, so let's jump into functions and their graphs. So we're going to look at an essential question today. What makes a graph a function or a relation today is my essential question. Awesome. So here we go. My domain is the x values that you plug in, or it is the input values. So we're going to talk a lot about this here in Algebra 2. We're going to talk a lot about domain and range. So your domain is the x values, or the values that you plug into or that you chug into a function, and their range is the y values or the output values. So these are the values that, hey, once you put in the x values, these are the y values that shoot out, these are the output values. Alright, a relation is any set of ordered pairs. A relation that's in the essential question there, it's any set of ordered pairs. So every set is a relation, no matter what. There's no restrictions at all. Anything that we graph, anything that we look at is going to be a relation. But a function is kind of where it gets a little bit more tricky. A function is a set of ordered pairs where every input there is exactly one output. Okay, so a function that is always a function is always a relation, but a relation is not always a function. Is that key thing there? All right, it is not okay for an x value to have two different y values. All right, but it is okay for two different x values to have the same y value. Okay, so we're going to look into this a little bit to see how this works. So look at a bunch of different examples here. Is this one a function or a relation here? So if I look, every x value for every input, there has to be exactly one output. So if I look at here, -3 maps onto 9, 3 maps onto 9. 4 maps onto 16, and 5 maps onto 25. So every single x value has its own, every single x value has a y value, so this is a function. All right. The next one, if I look here, 1 maps onto 8, but 1 also maps onto 10. This is a no, this cannot happen, so this is not a function, it is a relation. All right. Also, we look here, going down is the vertical line test. This is kind of the easy way if we're looking at an actual graph to see if every x value has exactly one y value. So if I look here, if I put all kinds of vertical lines here, if I look vertical lines all the way through this guy, none of these vertical lines ever hit this graph twice. So they can only hit the graph once to be a function. So this right here is a function. All right. The next one is I look here, if I put one vertical line right here, how many times does that hit the graph? It hits it 1, 2, 3 times. All right. So this is not a function. This is a relation. All right. So if I look here and if I kind of try to start to bring this in together, if I look here up here for this 1 to 8 and this 1 to 10. Okay, so 1 mapped onto 2 y values, so that's why that it wasn't a function. So if I look here, my line's kind of at like -3. -3 maps onto up here at, I don't know, 6. So my xy plane, right, or my xy graph would be 1, 6. I would have 1, like excuse me, this is like -3 is my x value. -3, 6, and this would be -3, I don't know, -1 maybe. The next one would be -3, -6 or something. All right, so that's all these points that -3 maps onto, so that's why this is a relation. The next one, if I look here, this vertical line test, that only hits it once at all of these parts, so this is a function. All right, as we move on down, we have these guys down here. We have, is it a function or relation? Same questions here. These are kind of on your own ones that I put for in-class discussion. That, oh, it only hits it once at all these spots. These guys kind of keep on going out and on and forever. This is a function. All right, this one, if I look here, this x value versus this vertical line, let's say we have an x value of 2 right here. It hits up here at 6 and -6, so this is a relation. All right, awesome. So every x value can only have one y value, not anymore. Awesome. So now as I look down here, equation in 2 variables, we're going to look at some graphing today in kind of the easiest, simplest way today. And this is what we're going to kind of have to go through. We're going to find solutions to an equation or an ordered xy pair that makes the function true. And these are going to be all equations that are in 2 variables. All right. So it's going to be y and x in here. So this little example here says, is 2, 5 a solution to y equals 3x minus 4? And the way that we're going to do this is we're just going to substitute it in and see if it works and see if my y is actually equal to 3 times x minus 4. So now I have an x and I have a y, so let's go through and plug them in. My y that I'm going to plug in is going to be 5 is equal to 3 times, now I just plug in my x, which is 2, minus 4. So I look here, 5 equals, what is this? 3 times 2 is 6 minus 4. Is 5 equal to 6 minus 4 is 2? Obviously 5 is not equal to 2, so this is a no. This is not a solution to this equation. All right. Independent variables are just the input variables, input values that you plug in here. So independents are the input ones, the x values that you plug into that equation. All right, so if I keep on scrolling down here to the next part of your notes for 2.1, we have the dependent variable. This is obviously the output. All right, the input was the independent, so the output is the dependent variable. That's dependent on what x value you plug in. That's kind of how I like to look at it. Graph of the equation is the collection of all points whose coordinates are solutions. Okay, so we're going to find a bunch of different solutions to this graph or to these equations here, and then we're going to connect that with some sort of line. It might be a curved line, it might be a straight line. We're going to learn all kinds of different graphs this year, and those are going to be all the collection points of whose the solutions are. All right, perfect. So here we go, the graph of the equation, or we're supposed to graph y equals 3x minus 2, and I just kind of have in here, I have a table for you with this -2, -1, 0, 1, and 2. That's kind of the generic way we like to do it. We kind of like to find out, hey, what does my graph kind of do right in the middle of this guy? So -2, -1, 0, 1, and 2. All right, and the way that we're just going to do that is we're just going to, hey, just plug them all in and see what shoots out for my y. So if I look here, if I have equals 3 times -2 minus 2. So all I'm doing here is plugging in -2. So 3 times -2 is -6, minus 2 is -8. All right, if I plug in -1, I have 3 times -1 minus 2. 3 times -1 is -3, minus 2 is -5. All right, if I plug in 0, I get 3 times 0 minus 2. 3 times 0 is 0, minus 2 is -2. So you can start to see this, and we're going to talk about this, is that this is in y equals mx plus b form, and you guys have seen that in Algebra 1, is that this line is just going to grow at the same rate each time. So if I look, this guy gains 3 to go from here, gains 3 to go from here. So if I'm going to plug in 1, I'm going to gain 3 more, so that's going to be -2 plus 3 is +1, and then 1 plus 3 is 4. So again, you go through, keep plugging those guys in, but that's kind of that linear relationship there. So now let's just go through and graph these. I have -2, -8, which is down here. I have -1, -5, which is right here. 0, -2, which is right here. 1, 1, and then 2, 4. All right, so those are the points that make up my line. You can see that it's nice and linear. I'm going to draw the straightest line I can through there. Not perfect, but you guys get the gist. All right, so that is my first linear function. Okay, so right there, linear function is a function that looks in the form y equals mx plus b, like I just talked about. X only has one only has an exponent of 1, excuse me, whoa. Notice how here it's just x to the first power. We're going to look at like x squareds and x cubes and x to the fourth and how to graph those guys this year. But this time we're just looking at x to the first power. And the graph, as we just looked at, is a straight line. Okay? Awesome. Quadratic functions are functions in the form y equals ax squared plus bx plus c. X has a exponent, highest exponent of 2. All right, so we're as you look here, this guy has an exponent of 1 here, but the highest exponent that you see is x squared, and the graph looks like a U shape. And if you guys remember back from Algebra 1, you guys briefly kind of looked at this in Algebra 1, that U-shaped is called a parabola. All right. And really, that's just what we're going to look into here. We're going to look into graphing some parabolas just the same way that we did before. We're just going to plug in some values and see what shoots out here. All right. Awesome. So as we look, it looks like we're looking at function notation. So function notation is just kind of a way that we like to write it in math to kind of save ourselves some time, to kind of, it's just function notation. You guys are going to see it a lot, and it's got this f of x. So instead of f of x, or instead of writing y, we write f of x, and that's just a function. Okay, so this is kind of like, as you look up here, f of 5 equals 13 means that the value of y is 13 when you plug in 5 for x. Okay, so here we go. It says find the value of f equals -2 for this one, or f of -2, that's how you say it. So all we do here is f of -2 is we just plug in -2 in for my x. So I have 4 times -2 minus 8. This is obviously -8 minus 8, which is -16. All right, that's that first one. So f of -2, and I should probably write that out here, f of -2 is equal to -16. All right, so as I keep on going here, f of 3 is what it asks for the next one. That one we just plug in 3. So f of 3 is equal to 4 times 3 minus 8. So 4 times 3 is 12, minus 8 is 4. So f of 3 is equal to 4. So that means when I plug in 3 for my x value, 4 shoots out. Awesome. So now f of 0, that last one there, f of 0, I just plug in 0. Hopefully this one should be pretty easy. This is going to be 4 times 0 is 0, minus 8 is -8. So f of 0 is -8. All right. So let's kind of put this into work here. So it says graph the function x squared minus 2x plus 1. All right, and it gives us some x values to plug in, and we're going to go through and graph. And I might not go through all these because I think you guys are going to get the gist after a couple, so I can kind of tell you what they are after we go through. All right, so first of all, let's find f of -3. So let's plug in -3 for all my x's and see what shoots out. So I have what? -3 squared. Make sure you put that guy in parentheses if it's being squared. Got to be there. 2 times -3 and plus 1. So let's go through and solve this guy. What is -3 squared is +9. This is going to be plus and negative, so I like -2 times -3 is +6, and then I have plus 1. So 9 plus 6 is 15, plus 1 is 16. So f of -3 is 16. All right, I'm going to do one more and then I'll tell you guys the rest of them. F of -2, then you guys will get the gist. So let's plug this guy in. I got -2 squared minus 2 times -2 plus 1. -2 squared is 4. This is going to be plus 4 again, and then plus 1. So 4 plus 4 is 8. Plus 9, or plus 1, excuse me, is 9. I gave you the answer there. All right. So f of -2 is 9. Okay, so if you guys want to practice on that, please go through, plug the rest of these guys in. But I'm just going to kind of shout out the answers here. F of -1 is 3. F of 0 is 1. F of 1 is 0. F of 2 is 1, and then f of 3 is 3. So you guys kind of see here that this is kind of the middle It's actually what we call our vertex point. We'll look at that a little bit later on in the year. But then you see how this is going to be 1, this is 1, this is 3, this is 3. All right. So that's not a -3. I don't mean to make it look like that. All right. So let's go 1, 0. 1, 0 is right there. 2, 1 is right here. 3, 3 is right here. 0, 1 is right there. -1, 3 is right there, and then kind of the rest go off the graph. But if you look here, these guys are kind of symmetric about this center point that I talked about. So if I look here, this graph keeps on going right here, and it keeps on, that makes my U. All right, so again, there's function notation, just trying to plug in those x's, those x values, and see what shoots out. All right, so thanks for listening to this video, these Algebra 2 2.1 notes, and have a good rest of your day.